So as we're solving these circuit problems for Riemann sums, we want to use this information that I've given you at the top. So let's go through the first one on the front page on the upper left. We have the integral from 0 to 4 of x squared plus 1 dx. How do we write that as a limit? Well, notice everything that I have in this information up here in black is always going to stay the same. So we don't need to know anything about the function to say that we're going to start out by writing it as the limit as n approaches infinity of the sum, where k equals 1, and we are going to n. What we do need to find, though, is we want to start out by finding delta x or dx. So in order to do that, we need to know a and b. So 0 is a, and 4 is b. And so we're going to do 4 minus 0 over n, which is 4 over n. And that's going to be our dx, or our delta x. Okay. The next thing we need to figure out is what's x sub k. So x sub k helps us figure out the endpoint of one of our Riemann sums, so we know what we're plugging in to the function to find the height. So in order to find x sub k, we need to know delta x. We're going to multiply it by k, and k is going to stay k, and we're going to add a. So we know what delta x is. Delta x is 4 over n. We're going to multiply that by k, and we know that a is 0. So this is really just 4k over n. So the next thing we need to do is we need to take this as an input for x and plug it into our function being x squared plus 1. So this is going to go into our function as x. So what we're really going to have is 4k over n squared plus 1. And if we simplify that, we get 16k squared over n squared plus 1. That is going to be our f of x sub k. So if we plug all of that in, we're going to get 16k squared over n squared plus 1. And then our delta x is our 4k over n. And that would be our solution for the first problem. So then the next question is, what if you're given the limit? How do you write the integral? Well, there's a couple things that we should notice. First of all, we can tell that our dx term here is 2 over n. So we know that delta x equals 2 over n. And whatever this thing is with k, this term here, that's going to help us figure out what our x sub k is, or and that helps us with our starting value, because that's where we can determine a, right? So I can say here that it looks like my function f of x looks like it's x cubed plus 3, because this thing here looks like my x sub k. So then that would tell me that my x sub k looks like it is 2 over n k, which would imply that we would have a plus 0. So that would tell us that a equals 0. So then as we're starting to write our integral, we can say that a is 0. And if our delta x has this 2 in it, that means that we're going to go 2 higher than 0, which is 2. Here we're just going to throw in our f of x, which is x cubed plus 3. And then we're just going to write our delta x as delta x. So that's really it for this one, and we're done. So if you have questions beyond that, or you need me to work out any other of the problems from the circuit, please just contact me.